Hi, in this video, I'm going to talk a little bit about some of the STP enhancements um, and different varieties of spanning tree, at least a little bit of an introduction. We'll talk about some of these in more detail later. Okay, so in this scenario here, we have a single root bridge for all of our VLANs. Okay, so that would be this distribution switch here is the single root bridge for all of our VLANs. Now, first of all, notice where we replaced the root bridge. Okay, somewhere near where it looks like where a lot of our traffic really needs to be directed to reach kind of either our servers or go out to our gateway, wherever it might be going. But it's a central part. It's usually not going to be an access switch. But also notice we have some redundant links here. And these redundant links, which are fine, these links here, are fine in case we have a link go down, then another path will be determined, like this link goes down, then maybe this link will become active. That's fine, and redundancy is good, but those links are going unutilized. So is there a way that we can better utilize all of our links and maybe do some load balancing at the same time? So let's take a look. What if we did this? What if we made distribution 1 our root bridge for VLANs 1 and 10 and made distribution 2 switch our root bridge for VLAN 20. Now remember in the bridge ID, we talked about the extended bridge ID and the system, the VLAN information that between the bridge priority and the MAC address. Okay, so that is what carries the VLAN information. And we can do this by using that extended bridge ID and a type of spanning tree initially introduced by Cisco called per VLAN spanning tree, and now a part of rapid spanning tree in a IEEE standard, which we'll see more in a moment. But notice here that now we're utilizing just about all of our links except for this bottom link here. And I left this here, but kind of typically in design, we don't have our 2 access switches interlinked like this unless we're stacking them. That's a different conversation. But anyway, what's important here is that you see that there's multiple links being used, which is good. We've also been able to load balance some of the load, some of the traffic, and we're using more of our links. All right, so a little evolution on STP. So spanning tree protocol, it's an IEEE 802.1d standard. Also known in the early days, common spanning tree or mono spanning tree. And basically we'd have one spanning tree process, one spanning tree topology, even if we had multiple VLANs. Cisco added some things like port fast, uplink fast, backbone fast. I'll talk a little bit about port fast in another video because that's a very important enhancement. And what happens, this is very common that happens in the industry, vendors try things out. And that's because the customers are asking for these things and requesting these certain kinds of enhancements. So vendors then add these enhancements to their model, to portfolio, to their devices, what I'm trying to say. And, believe it or not, vendors don't want to just have proprietary standards, okay? They want to make they don't want these to be proprietary. They want to make them open standards. So they work with all switches. So all of these enhancements became part of what was called 802.1w rapid spanning tree protocol. Okay, then what happened was Cisco introduced what we just saw, per VLAN spanning tree. And that allowed us to have different root bridges for different VLANs. Also added something called BPDU guard, root guard. I'm going to talk about BPDU guard and port fast in a later video because those are both very important enhancements. Okay, oops. So the problem, by the way, with having, let me actually use my tool here. Let me open that. There we go. Let me get to the pen here. One of the problems with per VLAN spanning tree is that for every instance, for every VLAN, you had running a different instance of spanning tree. So if you had, say, 100 VLANs, it was running 100 different instances, processes of spanning tree, even if those VLANs were using the same root bridge, the same topology. So what multiple instance spanning tree did, Cisco's version, later IEEE 802.1s, multiple spanning tree did, was that they said, let's do this. We can, if there's multiple VLANs all using the same topology, we can run those under a single process. So here we have two topologies, two different root bridges, but this one here only one VLAN, this has two. So it reduces the number of spanning tree processes. Okay. So we'll talk a little bit more about port fast and BPD UGuard in later videos. Also talk a little bit more about RSTP, rapid spanning tree, in a later video as well. Okay, so I hope this helped introduce you a little bit to the evolution of spanning tree.